Psyche mission to a metal-rich asteroid. The Psyche spacecraft is designed with solar electric propulsion, and the scientific payload includes a multispectral imager, a magnetometer, and a gamma-ray spectrometer. The mission is designed to perform 21 months of science. The spacecraft was built by NASA Jet Propulsion Laboratory, JPL, in collaboration with SSL, formerly Space Systems/Loral, and Arizona State University. Differentiation was a fundamental process in shaping many asteroids and all terrestrial planets, and direct exploration of a core could greatly enhance understanding of this process. The Psyche mission aims to characterize 16 Psyche's geology, shape, elemental composition, magnetic field, and mass distribution. It is expected that this mission will increase the understanding of planetary formation and interiors. Specifically, the science goals for the mission are: understand a previously unexplored building block of planet formation, iron cores. Look inside terrestrial planets, including Earth, by directly examining the interior of a differentiated body, which otherwise could not be seen. Explore a new type of world, made of metal. The science objectives are: determine whether 16 Psyche is a core, or if it is unmelted material. Determine the relative ages of regions of 16 Psyche's surface. Determine whether small metal bodies incorporate the same light elements as are expected in the Earth's high-pressure core. Determine whether 16 Psyche was formed under conditions more oxidizing or more reducing than Earth's core. Characterize 16 Psyche's topography. The science questions this mission aims to address are: is 16 Psyche the stripped core of a differentiated planetesimal, or was it formed as an iron-rich body? What were the building blocks of planets? Did planetesimals that formed close to the Sun have very different bulk compositions? If 16 Psyche was stripped of its mantle, when and how did that occur? If 16 Psyche was once molten, did it solidify from the inside out, or the outside in? Did 16 Psyche produce a magnetic dynamo as it cooled? What are the major alloy elements that coexist in the iron metal of the core? What are the key characteristics of the geologic surface and global topography? Does 16 Psyche look radically different from known stony and icy bodies? How do craters on a metal body differ from those in rock or ice? Psyche will fly a payload of 30 kilograms, 66 pounds, consisting of 4 scientific instruments. The multispectral imager will provide high-resolution images using filters to discriminate between metallic and silicate constituents. The gamma-ray and neutron spectrometer will analyze and map the asteroid's elemental composition. The magnetometer will measure and map the remnant magnetic field of the asteroid. The X-band gravity science investigation will use the X-band, microwave, radio telecommunications system, uplink 7.2 GHz/downlink 8.4 GHz, to measure the asteroid's gravity field and deduce its interior structure. The spacecraft bus is the Space Systems Loral, SSL, 1300 platform. JPL added the command and data handling and telecom subsystems and all-flight software. The spacecraft uses ion propulsion. It has 4 SPT-140 engines, which are Hall-effect thrusters utilizing solar electric propulsion, where electricity generated from solar panels is transmitted to an electric, rather than chemically powered, rocket engine. The thruster is nominally rated at 4.5 kilowatts operating power, but it will also operate for long durations at about 900 watts. Psyche will be the first mission to use Hall-effect thrusters beyond lunar orbit. The SPT-140, SPT stands for Stationary Plasma Thruster, is a production line commercial propulsion system that was invented in the USSR by OKB Fakel and developed by NASA's Glenn Research Center, Space Systems Loral, and Pratt & Whitney since the late 1980s. The SPT-140 thruster was first tested in US as a 3.5 kilowatts unit in 2002 as part of the Air Force Integrated High Payoff Rocket Propulsion Technology Program. Using solar electric thrusters will allow the spacecraft to arrive at 16 Psyche, at 3.3 astronomical units, much faster while consuming less than 10% of the propellant it would need using conventional chemical propulsion. Electricity will be generated by bilateral solar panels in an X-shaped configuration, with 5 panels on each side. Prior to the mission being moved forward with a new trajectory, the panels were to be arranged in straight lines, with only 4 panels on each side of the spacecraft. The spacecraft will also test an experimental laser communication technology called Deep Space Optical Communications, DSOC. It is hoped that the device will be able to increase spacecraft communications performance and efficiency by 10 to 100 times over conventional means. Deep Space Optical Communications, DSOC, experiment is NASA's first demonstration of optical communications beyond the Earth-Moon system. DSOC is a system that consists of a flight laser transceiver, a ground laser transmitter, and a ground laser receiver. New technologies have been implemented in each of these elements. The transceiver is mounted on the Psyche spacecraft. The DSOC technology demonstration will begin shortly after launch and continue as the spacecraft travels from Earth to its gravity-assist flyby of Mars. DSOC operations are planned for 1 year after launch, with extended mission opportunities to be evaluated. Palomar Observatory's Hale telescope will receive the high-rate data downlink from the DSOC flight transceiver. The Discovery Program solicitation offered mission projects an extra $30 million if they would host and test the 25 kg DSOC unit, which needs about 75 watts. It is hoped to advance DSOC to technology readiness level 6. DSOC tests should begin about 60 days after launch. The test runs of the laser equipment will occur over distances of 0.1 to 2.5 astronomical units, AU, on the outward-bound probe. Flight hardware: the DSOC flight laser transceiver will feature a near-infrared laser transmitter to send high-rate data to the ground system, and a sensitive photon-counting camera to receive a ground-transmitted laser. The transceiver's 8.6-inch, 22-centimeter, aperture telescope is mounted on an assembly of struts and actuators that stabilizes the optics from spacecraft vibrations. The flight hardware is fitted with a sunshade and protrudes from the side of the spacecraft, making it one of Psyche's easily identifiable features. Ground systems: a high-power near-infrared laser transmitter at the Jet Propulsion Laboratory's Table Mountain facility near Wrightwood, California, will uplink a modulated laser beam to the flight transceiver and demonstrate the transmission of low-rate data. The uplink laser will also act as a beacon for the flight transceiver to lock onto. The downlink data sent back by the DSOC transceiver on Psyche will be collected by the 200-inch, 5.1-meter, Hale telescope at Caltech's Palomar Observatory in San Diego County, California, using a sensitive superconducting nanowire photon counting receiver to demonstrate high-rate data transfer.